Hello learners, welcome to Ahmad Coaching and I'm your teacher Dr. Anam. Today we are going to study about biological method. The steps involved in a biological methods include observations, then comes the hypothesis, experiments, theory and scientific law. Let's study one by one. First of all, observations. The observations, they always begin with a chance. For example, if you are sitting somewhere and seeing something and suddenly observed something new, so this is a chance observation. For example, you are sitting on a beach and you saw the birds flying and you are just surprised, oh, the birds are flying, or you saw a specific bird and you didn't know the name of that bird, and you saw and you were considering that okay, this is not going to fly, but then you saw, oh, it's flying. So this is a chance observation. The observations, they are made with the five senses, including vision. It means that you are going to use your eye. Hearing, you are going to use your ear and you are going to listen to something. The smell by the help of nose, then taste by the help of your tongue, and touch by the help of your fingers or your skin. So by using these five senses, you are going to make observations, and this depends upon their functional ability. It depends that which sense of yours is working more correctly or detecting the signals. The observations can both be qualitative and quantitative. When we talk about the qualitative observations are related to the quality. For example, I have two plastic bottles. One plastic quality is very good and the other plastic quality is not as good. So I can say that okay, the bottle number 2 quality is better as compared to the bottle number 1. So this is, we are talking about the qualitative observation, while the second is quantitative. For example, I bought two water bottles and one bottle contains 2-liter water while another bottle contains just 1-liter bottle. So I can say, depending on their quantity, that here is 2L and here is 1L, I can say that bottle number 1 has more water as compared to the bottle number 2. So this is about quantity. That is why we are saying that this is a quantitative observation. The quantitative observations, they are more accurate as compared to the qualitative observations, as in the former variables are measurable, because you can measure the quantity but you cannot measure the quality. That is why the quantitative observations, they are best as compared to the qualitative. Moreover, not only you can measure the quantities, but you can also record the quantities in the form of number, like we have recorded that this is 1 liter and this is 2 liter. So this is how you are going to make the observations. After the observation, you are going to make the hypothesis. An observer organizes observations into data form and gives a statement as per experience and background knowledge of the event. For example, we said that we have two bottles. One has 2-liter water, the other one has 1-liter water. This is bottle number 1 and this is bottle number 2. So I can say a hypothesis, or I can make a hypothesis based on my quantitative observations, and I can say that bottle number 1 is good as compared to bottle number 2. Why? Because bottle number 1 is giving me more water while the bottle number 2 is giving me less water. Okay, so if in future I wanted to buy more water, I should go for the bottle number 1. So this is my hypothesis which I have given based on my observations and data, and the hypothesis is just a statement. This statement is hypothesis, which is a tentative explanation of the observation. Okay, so you are just saying a tentative explanation of what you have observed. There are two ways of formulating hypothesis. One hypothesis can be a result of deductive reasoning, or it can be the consequences of inductive reasoning. Now, what is deductive reasoning? Deductive reasoning moves from general to specific. and we use if and then in the deductive logic to make our hypothesis. For example, if we accept that all birds have wings and that sparrows are birds, so this is a general observation. We have observed that all the birds that fly has wings, and we also saw that sparrow is a bird. It means then we conclude that sparrows have wings. Okay, even if the sparrow is not flying, but still we can say that sparrow have wing. So this is if from the general observation you went to the specific. You have seen all the birds which are generally flying, and then you went towards the sparrow which is specific. So in the deductive reasoning we will go from the general to the specific. While in case of inductive reasoning, we move from specific to the general. For example, if we know that sparrows have wing and they are birds, now sparrow is a specific thing. And we know that eagle, parrot, hawk, crows, they are also birds. Then we induce that all birds have wings. The birds here, they are general. So from the specific observation we went towards the general observation. All right, so this is how we are going to make the hypothesis. The hypotheses, they are subjected to rigorous testing, and the testing is done through the experiment so that we can accept the hypothesis or we can reject the hypothesis. And when we will perform the experiments, we are going to collect the data and we are going to get the results. Any hypothesis that is tested again and again without even being falsified is considered well supported and is generally accepted. For example, we said that the birds, they fly because they have wings, and we said that sparrow is a bird, so it is also going to have a wing. If we are going to test this hypothesis again and again, and in the end this hypothesis is not falsified, it means that nobody can false it. It means that in the end this hypothesis is going to be accepted and we can say that the sparrow has wings. A series of hypotheses supported by the results of many tests, which in then called theory. So if a hypothesis is going to lead to more hypotheses, and then every hypothesis is going to be tested and is not falsified or is coming true, then that hypothesis is going to make a theory. A good theory is predictive and explanatory power. It means that a theory is going to whatever it is about, and it has the explanatory power. You can explain that why sparrow has a wing. Why? Because it is a bird. That is why the sparrow has a wing. So this is how the theory is going to work then. One of the most important feature of a good theory is that it may suggest new and different hypotheses. We can also come up with that, okay, we have an eagle and we know that eagle is a bird. It means that eagle will also have wings. So one hypothesis is leading to another hypothesis, and in this way we are going to make a good theory. After the theories, we will have a scientific law. If a theory survives and continues to be supported by experimental evidences, it will become a scientific law. That whatever happened, this is a law that sparrow is going to have wing. Eagle is going to have wing. So this is a law now. A scientific law is a uniform or constant fact of nature. It is virtually an irrefutable theory. So like I said that sparrow has a wing, so eagle will also have wing, any other bird will also have wings. So this is a law of nature now. In biology, we are short of laws because of the mysterious nature of life, and every single person is different from the other person. But there are some scientific laws in biology. For example, biological law of Hardy-Weinberg law and Mendel's law, which are related to the inheritance. So this is how the biological method works and moves from the observation through hypotheses, experiments, theory, and finally we will have the scientific low. So that was all about the biological method. If you have any question related to this lesson, you can ask me in the comment section. If you like this video, subscribe to my channel and also share this video with your friends. I will see you in the next video.